Welcome back to the garage, guys. So today we're going to make a pressure sensor for the Water Meth system on the M135i. We bought the pump second hand, so I don't know if it's configured right to be 200 psi. So I went online and they're about 50 quid for an old school gauge, and I'm not too keen on that. So I've got some electronics upstairs in the office, and we'll see if we can make our own, really. Shouldn't be too hard, so yeah, let's get up to the office. So we've got a bunch of different bits and bobs here that we can use to make the sensor and display panel. So we've got some ESP32s, got LED and key breakout board there for Arduino. I've got a R3, got a breakout board to go on top of the R3, got a TFT 2.8 inch display that we could pair with an ESP or an Arduino. But then we've also got this, which I do like the look of. It's a ESP32, but it's got a small OLED screen on it. It's packaged quite nicely, to be honest. I think we'll use that. What we've also got here is, this is a 300 psi sensor, so we should be able to wire that into that ESP, and it should package up quite nicely. It should be nice and small, instead of, we might make something bigger with this in the future, maybe a little vent display, but I think for now this will do what we need. So let's get into the code. So here we've got the bit of code I've written for this sensor display panel. So at the top you can see here, these are the libraries that I've imported in. I've got the screen config here. It's a 128 by 64 screen. Then we're going to set up the screen using the Adafruit SSD 1306. And then here you can see this is where I'm doing the initial config for the sensor. So I'm using a bunch of variables. I've got the max PSI, which is 300 PSI of the sensor I'm using. Then what I've had to break out a 12-bit reading into voltages. So the ESP is supposed to run 3.3 volts, but it seems to work with 5. So what I've done is I've taken the minimum resolution, so 0.5 volts in a 12-bit reading, which is 416, and then the 4.5 volts is 3750 in a 12-bit reading. And then what I've done for the next variable is the sensor maximum range. So the range of the sensor is the max resolution minus the minimum resolution, and that'll give us the range of values between 0.5 volts and 4.5 volts. Then here I've just got the setup of the display, the pins that the display is using, and then also I've got a 5-second intro screen, just to show what the device is. Then we've got the main loop here now. So this is where we're going to be constantly looping and doing the reads of the sensor and outputting it to the display. So we've got input 12 is going to be an analog read, and we put into the variable input P1. What we're going to do then is we're going to convert the ADC value, so the 0 to 4096 value, into a PSI value. So it's a bit of weird maths, this. I'm not good at explaining maths, but what it's going to do is it's going to take the input value, going to remove the first 0.5 volts, then it's going to times that value by 300, then it'll divide that value by the range value, so the 3750 or whatever it was, and then that will convert that 12-bit value from the ADC into a PSI readable value. Then we're just going to set up the display. So we're going to put WMI pressure at the top. We're going to output the Water Meth pressure as a string with PSI on the end, so we know what unit it's in. And then we're just going to add 0.5 second delay onto the loop, and that'll stop it updating too fast. We don't need rapid response, and it'll just make it hard to read when it's in front of you. So just put a 0.5 second delay, and that'll be more than enough there. So let's get on to the 3D design aspect. So here we are in Fusion 360. I've got an ESP32 board here, just so I can take some measurements. First thing we'll do is we'll create a plane on the top surface. That'll allow us to do our design. What we'll do is once we create that plane, we're going to project the sizes. So we'll project the edges, we'll project the holes, and we're going to project the screen size. That'll give us something to work off later in the sketch. So, you know, we'll know the position of the holes, we'll know the size of the board. You could measure all this out, but to me it's just easier. Just project it, model it, and jobs are good in there. So now I'm just going to define the board size and the holes, and also the window OLED display. So now I've defined the actual board size and the features that we need off the board. Now we can go about designing the box. So what I'm going to do is I'll offset the edge of the board by 2mm. That'll give us a 2mm border to work off. And then also I'm going to do an offset of 0.5mm. That'll just give us some room for the board. So if we did go the same size as the board and extrude up, it's possible that the tolerances will just be too tight and we won't get the board in there. So what I'm going to do is it'll be a 1.5mm wall. And also I'm going to do the same 0.5mm offset on the holes undersized. So there'll be a little bit of wiggle room for the holes, you know, for the pegs to line up. So once we've got all this defined, we'll be able to go then and extrude this out. So now we've got our sketch fully defined how we want it. We're going to move it over because I don't want the box to become part of the object. And, you know, I'm not the best at 3D model design, but it'll do what we need. So select it all, but unselect the little viewing window. We'll extrude that out 2mm. That'll give us a 2mm top surface. Then we can go to the back side of this body and we will turn on our sketch again. We can then extrude the pegs and the walls. We'll extrude them up 10mm and this will be the basis of our box there. So we'll send it to print and I'll get back with you. So 3D printer's just finished printing. Box has come out okay-ish. Surface finish is questionable, but it'll do for what we need. So stick up that. That's the back. I'm just going to super glue that on once I've put this in and done the wiring. I've had to bend the pins flat just to get it nice and low profile. I probably shouldn't have soldered the pins on, to be honest, but I'll solder the wires that I need onto there. And yeah, so ooh, fits like a dream. See that fits lovely. So I will get some wires soldered onto here to go up to the centre. I'll stick the board in because it's a little bit wobbly, but thought it would be. Get a bit of hot glue on there. Stick that on there. Right, so I've got the wiring done for the display. Got the pressure sensor connected. Got a little, I think that's 1/4 pipe thread to 6mm pipe, so we can just tee directly into the feed there. So it's going to be hard with one hand, but let's see what we can do. So we've got the display here. Display here. So plug USB power in. I don't know why it does this weird line thing, but you can see that it's loading up. And then you can see it's reading 0 psi. So yeah, we'll get out to the car and we'll give it a test, see how it works. So what I've done is I've just popped the line coming off the solenoid, put it into the pressure sensor. Then if we jump into the car, you can see got the display there. So if I just turn on the system, then we'll hit the test button. So about 175 psi there. So yeah, that looks good, all working. What I'm going to do is I'm going to tee into this line here and then be able to mount this somewhere, not sure where, maybe in there. so it can live with the... Oh, you're upside down. So yeah, I might mount it in there so it can live with the thingamajig, a little controller. So yeah, there we go guys. Really happy with that, and yeah, I'll see you next time. Cheers. Watch all videos, like, share, subscribe, ring that bell.